All right, Unit 2, Lesson 3, Warm-Up. Looks a little different. There's a little terminology we want to make sure we have down for stuff that's been going on. Basically, for this one, I'm looking for a definition of horizontal. How would you describe something that goes horizontal? Obviously, that's horizontal. How would you describe that? I would say runs left to right. Okay. It's flat. A horizontal line has a slope of 0. Okay. A vertical line runs this way. It's not number 1. It runs this way. So it runs up, geez, I can't write, and down. Sorry, this is really sloppy. And has a slope that does not exist. Okay. The ordered pair that represents the origin of the graph. There's the graph. There's the origin in the middle. The ordered pair that represents that is 0, 0. The y-axis is the horizontal axis. Horizontal axis in a rectangular coordinate plane. That's the x. The y-axis is a vertical axis, which is this one here. Okay. Goes up and down. Gotta know those. One of the properties of a straight line on a coordinate plane is its slope. Its symbol is an M. It means, however you want to word it, the extent to which the line is slanted, tilted, however you want to say that. The slope formula, m equals y2 y1 over x2 minus x1. What is the slope of the following? Let's see. So this would be x1 y1 x2 y2. So it would be negative 4 minus a minus 3 over negative 2 minus, oops, whoa, hang on. Negative 2 minus a minus, where'd I go? 4. Make these pluses. So this is negative 4 plus 3 would be negative 1 over negative 2 plus 4 would be 2. So this would be a negative 1/2 for my m. It's a negative slope. If you want to visualize that, let's see, negative 4, negative 3 has got to be down here somewhere. Negative 2, negative 4 has got to be down here somewhere. So that's kind of goes like that. That's not a bad way to check that it's supposed to be negative. Okay. It is. The answer is 1/2 though. Negative 1/2. All right. That we have a equation here. I don't want you to get thrown by things a little out of order that we're used to. It can be written in any order. When you're working on them, you can write them in any order as long as you have the appropriate signage and the right terms with the right terms. So this is kind of function notation. If you're going on to 92, this is how things are written. The C of m, when m is a certain number in the equation, C turns out to be that. We're used to just C being on the other side, and we're used to this being 175m plus 4. The 175 is still the rate, okay? The m is still the number of something. And in this case, let's see, what are we talking about? Charges for a trip. How many number of something needs to travel to their destination? I'm going to go with miles. Okay, so just because it's an M, you can't think it's a slope in the context of a word problem, okay? Because what is the slope? That's the slope. The 1.75 is the rate or the slope, okay? The M, the letter M, is standing for the number of miles, okay? And 4 must be the start rate, and then eventually C will be the end. So that's how you read that. So the C of M represents the total charge for the trip, or the N number. Total is what they're looking for here. 4 is the amount charged for, this is taxi service, by the way, charged for any ride, right? Any ride. You get in the door, it's $4. Then how many miles you go, okay? The 1.75 is the slope, or the rate, or the cost per mile, multiplied by how many miles is the, let's go with rate. You can also put slope, equally acceptable, okay? It's the rate or the slope, the positive 174. It is multiplied by how many m's, which in this case must be miles. S must be the number of miles a customer needs to travel to their destination. Okay, that's just another way you're going to see the word problems. Okay, now we're going to go back and practice something you don't like that was in chapter 1.8 that had to do with simplifying and solving for other letters. Okay, so notice that there are two letters. Let's see, I should start with A. Let me go over here. Notice that there are two letters, two variables in this problem, actually three, R, X, and P. This one says make sure we get the P alone on one side. That means we're moving other terms away from it. Okay. That leaves me my negative P. Don't forget that negative goes with the P on that side. And over here, these are not like terms, so do not add them together. So that goes here. All right, and I need a P alone, not a negative P, so I need to divide by a negative 1. P equals R minus 2X minus over a negative 1. I would accept that. Another answer that you could put for that would be negative R minus 2X, which is also P equals a negative R plus 2X. That's what you'll probably find in the book if you did that. But I accept any one of those three answers. This one here, that one there, okay? That's how we distribute, or actually how we divide by negative 1. You have to run that through there. It's a little tricky. Let me write something down, then I'll erase it. Some people take the R and divide it by a negative 1, and then the negative 2X and divide it by a negative 1, if that makes more sense to you. So then this is kind of a 1 divided by a negative 1, which is a negative 1, or negative R. Negative 2 divided by a negative 1 is a positive 2X. So that's how you're getting that. Okay? That might be a little easier to see that way. In fact, let me do that over. Let's just start doing things. I know we were kind of doing them for expedience sake before, but let's follow this through how you're going to use it with this chapter. So let's see, we move the 2x. There's no discussion about that. This is R minus 2x equals negative P. Need to divide by 1. Geez, we need to stop writing this whole line underneath now. Let's divide this by negative 1 and this by negative 1, okay? That is a 1R. So a 1 divided by a negative 1 is a negative 1, so negative R. A negative 2 divided by a negative 1 is a positive 2x equals P. That's a better way to go. I like that better. Okay, we need to start doing that. All right, let's see. Down here, this has got a fraction in it. We can clear the fractions. I like to move things out of the way because I don't really need to clear. Remember that clear the fraction move. The clear the fraction tool can be used anytime in your orders of operations. So I find it easier to not run it through a whole bunch of other numbers. Okay, so since I can move that 3 over, I'm going to move that 3 over. Remember, we're not moving the 5 to the right. We want things on both sides of the equal sign, so do not move the only thing you have over there. So the only thing you should be doing is moving the 3 over. Now you can run a 9 through the whole thing to start with, but I'd really just rather do it here. Okay, it saves a step. Remember, that 9 comes out, that leaves you with the 4. And this is what, 72, I should get my key out. Yes, and then divide by -4. So let's step it up a little, those of you that like to clear your fractions first, and recognize that you can move this so you're not multiplying that by so many things. It just leaves yourself open for more errors to make. So let's see, we have -72 divided by -4 actually goes in 18 times, so that's a positive answer. Okay, so look, I had 3 variables here, I only have 1 here. You got to be a little more flexible now. We got to change as we go. All right, this one has a p and an x, and I'm solving for the x, so that means I'm definitely moving the 4 first. Okay, don't move the one that's got what we want. Don't move the p, that's the only thing on one side. So really the only thing you can do is add the opposite to move the 4 to the other side. So you're going to have p plus 4 equals 2x. They are not like terms, do not add them together. Then I want x alone, put a p and a 2 under here and a 2 under here. So p over 2 plus 2 equals x. So that would be a good answer. I will accept it if you turn it into p over 4 over 2 equals x. That's fine. I just want you to try starting to do this one, okay? All right, here we got a t and a p. We're solving for t, so that means I want to move the 8p. 4t equals, let's see, 4 plus 8p. They're not like terms, so I'm not putting them together. And I'm concentrating on getting my t alone on one side. And for this one, since it's a 4, I would still get used to start going like this. It's just a better way to do things now that we're kind of pros at this. 1, that's 4 over 4 is a 1. And then 8 divided by 4 is 2p. Let's do that. Okay. Solve for p. Let's see, solve for p. That means I need to move this thing over there. I don't know. I probably should clear the fraction first, but let me see what happens if I just do this. This is p equals 3 minus 65. You know what? That's fine. There's nothing wrong with that. In fact, if you notice, this is this could be a rate, a -6/5 m, like times number of miles, plus 3. So that's another accepted one. If you happen to have cleared the fraction first, you're going to get 6m plus 5p equals 5 times 3 is 15. And then you're going to have to move the 6m over. So 5p equals 15 minus 6m, or -6m plus 15, whichever you want. But then you're going to have to divide by 5. Okay? So that's going to give you p equals the 3 minus the 6 over 5. So you're going to get there. So look at that. So in this particular case, you just made more work for yourself by distributing that, by clearing that 5. Because I wanted the p and it was already alone, I'm not going to take the time to clear that fraction. Just keep it. Remember, this is what some of these word problems look like now. Just have that negative slope in there. Okay, so just keep that.